Good afternoon. Thank you all for joining us for this next presentation in the Signal Innovation Showcase Series. I'm George Seifers, Editor-in-Chief of Signal Magazine. For this presentation, we will be joined by Ivan Wallace with the U.S. Federal Technology Office at CyberArk, and he is going to present us with some innovative ways to accelerate DevSecOps. So, Ivan?
Yep. All right. Thanks, George, and thank you for taking the time out of a busy day to come by and learn a bit about the world of DevSecOps and how it's kind of merging and how it's constantly considering all the different identities out there. And so, as a background, actually, I came from the Venafi acquisition, and so a lot of this will be kind of focused, obviously, on the overall the overall ideas around how do we secure DevSecOps with around machine identities and secrets management. So hopefully you'll come out of this with some insights, and let's get going. So as you may or may not know, so CyberArk. The CyberArk Identity Security Platform, basically, if you think about all the different access parts in a network, right? Typically humans, typically machines, and they'll have to authenticate and be authorized to access resources. And so it's becoming a very critical part of the spectrum of identities. And so in this graphic, you can kind of see it just extending all the way from the workforce, from IT, and in particular the developers that are pushing all this code, right? So we'll get into a little bit about, well, how do we create and manage all these different identities, both from developers and users? How do they merge with authentication and authorization? And then we'll also get into a bit on the software supply chain security, just because we're going to be kind of merging in machine identities with a bit around code signing. If everyone's kind of heard of code signing, that fits in more to the software supply chain security model. And so really, it's all about considering all the different parts. So the human components, and then all the different machine identities that are interplayed, right? Through federation, through what's required when you want to build some software. Which identities, which developers are going to be kicking off that pipeline. What code do they have access to? And finally, when it comes to deployment, you have the platform engineers. They also have to have some type of standing access or standing privilege to be able to deploy this code, right? And so I like this slide because it poses the challenge of very diverse application and development environments. We consider most cases, a lot of organizations have a bit of the cyber debt, right? So they have existing infrastructure. They have maybe some mainframes, long-lived applications that it's really hard to change. So how do we consider that? And on the flip side, what about more of the cloud native? What about more of the ephemeral nature of some of the modern applications, right? So we talk a bit about cloud, makes sense, right? With Kubernetes, there's development tools, right? Folks are, and you can kind of see here across the chart, there's container platforms. So once again, the ephemeral nature of those environments. Development tools. So as I mentioned in the first slide, so we have a developer that wants to be able to write some code, infrastructure as code, right? And there's different flavors, right? Everyone's heard of HashiCorp, Terraform. There's GitLab, right? Jenkins. There's a lot of GitOps happening, right? To be able to develop code and push it out in real time, and all the way to security solutions, so being able to monitor and secure those applications, custom applications too. So as mentioned, we have a developer that wants to be able to right, develop some code. Maybe they're pushing out a container image that is going to perform certain activities. So how do they do that in a secure fashion? So we'll kind of break those down into small pieces here. So I like this slide here because I kind of break it down into 7 different components. It's a bit of a busy slide, but it really talks about the first entry point into your organization in terms of developing and deploying code is going to be that developer, right? So the developers, in a sense, the developers are probably maybe they're the first ones that are being targeted by a lot of these malicious actors, right? So social engineering is one form, whether it works or not, depending on the developer itself. So there's lots of ways for spoofing, phishing to be able to land into these environments, right? So take it one step further. Once we get access, potentially, someone lands in the environment, maybe lack of controls around those particular servers, that opens up a lot of opportunities, right? So they can exploit local password stores, session cookies, remote access tools, and so that's going to be the next phase, right? And then, of course, from there, extending access to these systems with limited security controls, which means you can abuse or misuse a lot of these credentials. So high levels of privilege, probably the number 4 point. So they allow you to compromise, as everyone's aware of SolarWinds. So being able to compromise a development pipeline is a common, I would say, a much more sophisticated approach. But once again, we're really right. The malicious actor is already, potentially exfiltrated data. They're in the network, and they're potentially misusing the CI/CD pipelines like a Jenkins run. And so there's a lot of broader lateral and vertical movement that can happen, as you can see here in this diagram, all the way from cloud native, right, being able to take advantage of federated, where you're able to almost impersonate a user, right? Assume role is a good example of that. So that allows them to then push out their own elastic workloads, and then finally, maybe the living off the land attack is where you can actually take it. If you have one of these longer lived systems or you're already in there, you have the ability to compromise and to basically you have a longer time frame before you're potentially before you're discovered. So once again, really from the developers for where they're building code, all the way to the runtime, these are all, we might think it's just developer access, but it's the entire spectrum, right, that we need to consider. So how do we address these challenges? I like to kind of break them down into 3 different areas, because we know the developers are building code, right? They're utilizing DevSecOps to be able to of course, introduce libraries, create those applications, and then deploy them. And they might rely on hard-coded secrets. So makes sense the first place to start to identify, and then understand where the machines and also the applications, because there's in a sense when you built those applications, some developer, some pipeline, deployed them. So you want to be able to start establishing or mapping that identity to the different machines or applications or workloads, as we're calling them these days as well, and go from there. And then, of course, from a secrets management perspective, so we have the developers who may be, of course, leveraging those secrets to be able to automate. Once again, automation and security. Sometimes how do we balance that aspect of it, where we can continue to move at the speed of the development, in automation, but at the same time, avoiding the islands of potentially where they have just decentralized credentials and decentralized authentication. And so when we start to look at removing hard-coded secrets, we actually have to make sure we limit the discovery. So once again, take a look at your build environments, take a look at your pipelines. So limit the potential attack surface, where you can go in and take a look at what environment variables or what types of secrets are there. And so a benefit, the win there is going to be the compliance team audit, and of course a security best practice. If you are going to have those short-lived credentials, then maybe use the notion of such as a workload identity, or be able to, for example, use an OIDC, a JWT token to be able to make that attack surface as reduced as possible. And I mentioned the security island dilemma, where you have pockets of decentralized access, right, where you lack the visibility into seeing where those credentials are, and at the same time, it's hard for you to rotate those keys and rotate those identities, secrets. And so, where I came from the machine identity side of it was being able to, of course, establish that identity. Map for those of you familiar with PKI and certificates, being able to give that cryptographic identity home to a specific application. So once again, we know we're issuing digital certificates, and those are tied to an application. And we have, basically we have full visibility into where those certificates, first of all, who's issued those certificates. I've had discussions with some of folks within organizations. Sometimes they don't know who's issuing those digital identities and those certificates. So let's understand that and give a more of a centralized log and an audit trail of where those certificates have been issued from. And then from there, it's just a kind of a continuation where we can extend how applications are going to be authenticated. A lot of them are going to be based on zero standing privilege, where we have some form of federation, but there might be an additional form of workload identity that is going to identify maybe a very short-lived container that's going to be running. And then finally, right, so removing the hard-coded secrets, we're starting to map maybe developers, the development team, to which applications they're going to be creating. We're now taking even a machine, whether it's a load balancer, whether it's a web server. We're starting to map that identity, so we have a trail, and we can see how they were stood up, and what access is. It even enables zero standing privilege in that access perspective. And so with secrets management, of course, these are more of the short-lived secrets that we're introducing into our pipelines. So of course, either you rotate them, or you use workload identities, and you go from there. We obviously do not want to minimize how we rotate them and how often we do that. And then finally, when we think of the overall picture, you're obviously introducing more automation. So how do we make that and prevent the downtime that it takes to rotate those secrets? And so moving right along, so kind of a nice summary, at least of this portion of the presentation, is I call it invisible infrastructure or an invisible security, because it's all the way to a developer such as myself, where I have a laptop and I'm authenticated in, and I'm federated to a specific automation tool, to my development tools. And then I consider all the different use cases, right? Operational access to cloud native services, to VMs and elastic workloads. And these are just examples of those workloads. Makes sense, right? All the way from the elastic ones, just in time, to more of the Linux, maybe the ephemeral Kubernetes clusters, all the way to even your managed services, where we can have that protection and monitoring. And a quick pivot over to, right, we talked about identities, hard secrets, and it's really about extending that model to applications and machines. We want to make sure that it's code that we trust, right? So examples of AnyDesk, SolarWinds, macro updates, policy within Kubernetes. These are all different attacks, right? The AnyDesk was a revoked code signing certificate that's signed in AnyDesk remote for remote access, right? So these are good examples of why we should extend this model to be able to sign, to be able to have a very strong supply chain, right? Especially with software. And so, so quickly here, it's, in my opinion, that this code, just like an application, just like a machine, has an identity as well. And how do we do that? Well, we do that with cryptographic mechanisms. So we take some code, we take the digest, we encrypt that with a private key that creates the digital signature, and at that point we have a mapped identity to the code, and at that point allows us to write end to end. So our signed code, as you know, we're taking advantage of the cryptographic properties, so we get authenticity, we get that integrity because it hasn't been tampered with since we released it to the time that we deployed it. We get the verification and the policy enforcement, using such as CyberArk's EPM solution, where we can actually at runtime prevent code from running based on a trusted identity. And then finally here, I wanted to run through just what is the anatomy of that software supply chain, right? So we have our local build. We have so a developer, assuming that we have access to the appropriate system. Maybe we're doing code analysis, we're doing testing, right? And here's some examples of for those of you that are working with the government in terms of the Fed and some of their software supply chain mandates, being able to create that software bill of materials and having that attestation around that, all the way to automated builds. So as I mentioned in previous slides, being able to automate that securely through GitLab, through GitHub Actions, Jenkins. There's a whole bunch of different tools out there. And then finally, we distribute that code, and we have to do that by scanning, and then of course, having that content trust. We code sign using a solution like Code Sign Manager, and then we push those artifacts to a deployment to your repository, where it can then be orchestrated, right, to be able to push that code and then have that run in real time and used in policy enforcement, such as via Caverno, using Open Policy Agent, using Ratify. These are all admission control policies that are going to be really good for enforcing the runtime. So really a good slide of summarizing just what happens from a developer creates the code, using an enterprise pipeline, being able to use what's available in the organization. We want to have that trusted publisher status, which means that the enterprise has to have a trusted root or that trust chain, and then it allows us really to really enforce at runtime the code that we produced. And so just in conclusion, right, so we talked a little about the DevSecOps experience, and really CyberArk's in a good spot, right, that comprehensive solution that we can secure all the machine identities, right, from secrets management to zero standing privilege, being able to control who has access, right, from code signing to SSH, certificate lifecycle, which the world that I came from as part of Venafi. Being able to incorporate that into the entire, I call it the entire trust chain, right? So solving new use cases, right? Long-lived systems, container native, or cloud native, and some of the emerging problems, especially around post-quantum, right? And so that's really what I wanted to discuss, and hopefully it was useful, and appreciate it. Thank you. Yeah, if there's any questions, let me know. We can take it offline as well if you have specific questions. Yeah, thank you.
Ivan, thank you so much, and thank all of you for being here once again. Our next session will be in 10 minutes.